Okay, so check this out, right? I want to show you something. I've been working in the past, I would say 2 years or something, on this project called Workspace. Really started when I realized that Docker and Kubernetes are both written in Go. And so, like, there was this idea of, can I use them as a package, right? I started experimenting with the APIs of both before that already, but I wanted to go a step further. So in any case, let's run this project first. Go run main.go run, and it'll give me some deprecation errors on the new Mac. And yeah, it will error out. Sorry, my dog is kind of nervous. We recently moved to Spain, and very recently last week, and yeah, he's been kind of getting used to the new house. What we see here basically is like I'm not sure how familiar you might be with Kubernetes and Docker. I believe, if I'm correct, it is the system that they use to basically like do integration tests on the CI/CD for Kubernetes itself. But we see here, kind of familiar, if you are familiar with it's starting up, right? So if I just scroll back a bit, we can see that, yeah, it's actually it's dumping a lot of information that's to do with the way that I sort of monkey patch the logger, but it's creating a cluster called Workspace, because that's the name of my project, and it's making sure that it has the Docker image for the kindest node, which is basically Kubernetes 1.24. So I think that's the most recent edition. And then it's preparing the nodes. These four boxes means it's actually making four nodes, and then it's preparing the nodes, writing the configuration, and then it's actually starting to apply these YAML configs to set up Kubernetes for us, and that's Kubernetes running entirely in Docker. So you do not really mess up your system or anything. Um, it is actually a full-blown Kubernetes running in Docker. Um, and so yeah, this is all basically like it's doing etcd there, deploying everything needed to have a basic Kubernetes cluster with one control plane node and three worker nodes, I believe. But you can do as many as you want. And then yeah, it's starting the control plane, installing the CNI, which is I believe the networking stuff, um, the networking plugin, and then so installing the storage class, of course, because you need storage. And I'm not sure whether or not this was actually using OpenEBS. I believe so, but I could be wrong there. Could also be that it's using actually the underlying storage layer of the system, I mean. Um, and then so let's go to the end. I know that it errors out here because I was at the sort of the front end of starting to also incorporate Minio, but the real cool part of this, before I show you, I will show you that like right now we have these four uh, Docker containers running, one of which is the Kubernetes control plane for and then the three worker nodes. And I'll show you how I did this, because this is not using like the shell or shell commands or anything. This is actually the code is being used as a package in my Go code. So it's actually fully integrated, like it's compiled with with my program. And so if you're into Go, then you probably have seen the Cobra Commander stuff before. Forget about this. This is Pyroscope. I will show you that one day. But basically, our entry point starts here at the command directory, and there is this run command that is the stuff that we just ran, right? And so I create this new type called a cluster, and if we jump to that, then we see that yeah, it's very simple type. Like it has a cluster type, which is this enumerator here, this enum. And basically, what I wanted to do was like, okay, so If you are on your local machine working on it, I wanted to be able to deploy the kind Kubernetes cluster because that's easy for your local machine. But I also wanted it to be able to just connect to a remote system because just creating the Kubernetes cluster was not the idea of this project, but it was the foundation of it. Um, and so yeah, then it will run provision, and in this case, like, yeah, it's kind of sort of shelling out to the terminal, but it really isn't. This is the way that I finally managed to do this, which because I couldn't find a good entry point, and this was actually really an issue when I was working on trying to integrate Docker directly. So the idea would be like you have this one binary. You wouldn't have to install Docker. You don't need to install anything. It all runs from the binary because it's all compiled in it, right? And to do so, like because everybody basically in the Go world is either using like Cobra Commander or whatever, that gives you the entry point that you're looking for. And so that's what I do here. I actually just like um, basically like if I jump into it, I am now in the package app of like the Kubernetes repository, yeah, the code base. And so like they have this run command, right, where if you use kind like on the terminal like this, it has this whole CLI interface. Well, that CLI interface is actually coded here, and you can tap into that. As soon as you do so, it becomes part of your code, right? So now we have a way to start Kubernetes clusters from our code base. We are not shelling out to the terminal. We are really just yeah, going much deeper than that. And so once you have this, right, like now you have your cluster running like we saw, and we can actually use kubectl on it. I'm not sure if this will actually be already configured for you. I believe it will be, but let's see. It is, right? So okay, it also immediately adapts your kubectl with a new context, so that's great. Now that we have this, right, so what I would do, well, what I was doing was actually trying to deploy Minio on it, but forget about that for a second. Now you can actually use the client from the Kubernetes API to go again further than that, right? Like now you can apply Kubernetes configuration files directly from the code, right? So like you're no longer using like YAML files, although you could, but we're like I'm not, right? Like so, and I believe this is actually yeah, this is a new version, so like not everything is there yet, but I can show you in another way. I can show you in the old version how that, or I can show you in a different version. Let's just say that how that would kind of work. So I'm actually gonna quickly go into here, and then I will go to this repository. Where is it? There. And we'll have a look quickly in, I think it might be infra. Yeah. Yeah, yeah, yeah. So if you have experience with the Kubernetes YAML files, this will start to look very familiar to you very fast. So let's look at deployment, right? You would normally have this deployment YAML. Now, on the back end, inside of the Kubernetes code, that YAML is obviously interpreted and, made into structs. Those structs will look a lot like this, right? So object meta, meta v1, object meta. This would be if we did take like a if we quickly pulled a deployment YAML somewhere. Let's see. Whoop. Let's just take any one of these and go into the deployment YAML. Right. So, this API version actually apps v1. I believe here no, I'm using apps v1, right? So that's actually interfacing with this particular sub package inside of the K8's code base, right? And so forth. And then you have like the metadata and like the app and the namespace and the name. metadata, right? Like object meta, right? The name. So these structs, they are kind of very similar, actually kind of entirely similar to the YAML specs that you are familiar with. Um, by doing this, obviously, we get some form of programmatic access to that. So now we can do much cooler things. Like the idea in the end of this project workspace. Well, it started out as me wanting to simplify I guess Docker workflows, right? So what I wanted to do, and I wanted to make my entire like if I go to a new machine, right? And for instance, like this is always my example. If I want to use Nmap, and I want to scan, my local host, for instance. Well, first I have to, obviously brew install Nmap to do that. I figured, like, what if I had like just one binary that I would just take with me to a new machine? I would install it, and then I would alias it somehow, for instance, in the Z shell config or in the Z shell RC or in the bash RC. And then whenever I type, a command, instead of me having to install it, it would be proxied through this binary. And the binary would then look like, hey, do I have currently on this machine a Docker container that contains that command? If not, then let's pull it from a private repository or even a public one, and use it directly from the container, which means I would never have to install a machine again with all my favorite tools. And if I am on somebody's machine that isn't mine, it's easy cleanup, right? Like if I want to use all kinds of tools, and then I just sort of like do a Docker system prune AF volumes, and I've cleaned up everything that I've done. And this all came from like a job I did, I guess a few years ago now in 2020, where people were kind of hesitant to use Docker because they weren't very familiar with it, and I wanted to take that sort of that doubt away by saying like, okay, so don't no worries, like we will just install a binary and then everything starts working for you, right? Like so that idea evolved a lot, wherein now what I wanted to do, and I came very close with this actually with this particular version. What I wanted to do was basically I wanted to unify development, production, all the stages in between, right? Including day two operations. So the idea being that like I think it was maybe run, it could have been provision. It's probably provision. Yeah. Um, the idea was to actually have this one project, this one binary that is in Go and compiles to a single binary, that not only you wouldn't have any, you wouldn't need to install anything, not Docker, not Kubernetes, nothing, right? Like it would all be compiled directly into the binary and used from the code directly. But it would be able to set up its own infrastructure and deploy itself onto itself, basically. And let's see if I can find where I got reasonably close. Um, this could be it. Yeah. Here I'm even going as far as having Istio also directly um, integrated. Although I may have cheated here a bit. Let's see. No, this is still pretty good. This is still pretty good. So this is actually indeed compiling Istio directly into the binary as code as a package, and yeah, deploying Istio, onto the kind cluster that would have been deployed of provisioned before. So I would see that. Let's see, where am I deploying? Here I'm deploying the cluster. Guess with one node or something. Yeah, one node. And then I would start the cluster, and then I would deploy Istio on top of that. And then I had this idea of like having the building blocks to build services as well inside of uh, the code, right? Like, so it's like one repository that has building blocks for services. Um, I guess yeah, this could be it. Yeah. Although, yeah, this is the one part where I cheated a bit, I believe, where I actually compiled kubectl into, yeah, I compiled kubectl into the binary as well. That turned out not to be entirely necessary. Kubernetes has a new kind of cool trick for that, but I will go into that in another video. What I did was I created this sort of like concept of an architecture, which is like a an aggregation of services, and I believe I did something with storage as well, or maybe not, or with data stores. Well, in any case, what I'm seeing here is that I just have the services, and then you would have like you would add a connection to it. So in this case, it would be a service that starts a new HTTP server, right? Because what do you want for a service? You want to be able to call it as an API. So I'm basically composing that out of like these little building blocks that I have, and indeed I do have some storage here. This would be S3 compatible storage, but I was trying to make it faster. And so you would build this sort of architecture. Let's say like you would want an HTTP server, some S3 storage at the backend, or whatever, MySQL or whatever. And then like it would be able to deploy that onto itself, right? So that's what it kind of does here, where it um, yeah, it goes and takes the services, and then let's see, yeah, it brings them up. Okay, that's good. Not entirely seeing the deployment here happen. The way that the deployment would work would be to basically, um, yeah, I can show you actually. It would actually call a command in itself, which would be I guess serve, and serve should have, okay, I guess I deleted that because it was throwing errors maybe. I I, I honestly thought it was that one actually. Um, but the idea would be to basically yeah, call a command on itself. So like we have the binary. The binary can be aware of itself. Obviously, if you shell out to the terminal, you can access that binary, and basically um, using the Docker API, um, copy that binary like from the code, right? We're currently running the binary, running the code. From that code, we would copy the binary into a Docker image or into a Docker file, basically, but not a real Docker file. The Docker file would be, um, you know, made out of code, right? So if you looked at the Docker API or something, or I think they call it the SDK actually. Um, yeah, Right, the Go SDK exactly, and then so you could look at an example here. It's actually, well, this is actually pulling the image. I guess they kept it quite simple, but you can also build the image yourself, and again, it will look very similar to what you know from Docker files, like even, or in this case the Docker command, right, where you have the command and the TTY, like, so it's the TTY would be if you did something like Docker dash ti, right? That's, you want to have a handle on the terminal interface, and so yeah, it would be, so the project would run itself, and then like shell out to the terminal, um, pick up that binary, but now with a different subcommand on the CLI to actually say like, okay, well, this time don't provision an entire cluster. This time just run yourself as a service, and run yourself as this particular service, which is like a key inside of that whole architecture stuff that we just saw. Only I need to go to the right thing. So the architectures, I believe, would have a key. Yeah, exactly. So here we have a base architecture, and we have a service called information disposal. And so, like, if we said like, okay, well, workspace, serve dash name information disposal, it would eventually lead you to here. It would run this part of the code, right? It would basically ignore the rest. And so if you brought that all into a Docker image, and then deploy it onto that cluster that we just built here with a TTY that goes to that pipes back out to your local system. Now you actually have your little service, and of course you can also expose it as an HTTP endpoint. And so that's what I've been working on. So it's kind of like, you know, it's like, okay, you have your development environment, but it is its own infrastructure as well. So it can actually go all the way to production, basically. And it doesn't necessarily end with, using either kind or using an existing cluster, which is what I sort of hinted at in this infra bit here with the cluster part. Because, yeah, so was it here? No, actually, that I should probably go back to this part of the code. I'm sorry, I have so many versions of it. I've been working on this for like, I think 2 years or something. So, yeah, so here, let's jump. So now we have kind and we have remote, right? So we can make a Kubernetes and Docker, which is definitely not production ready. And we could be remote, but that means we need to have an existing cluster. That sort of defeats the purpose, right? We wanted to have a an end-to-end, solution. I call this infrastructure is code, not as code, but is code, right? And so like, but we might as well just like, do a kube ADM, like kube admin cluster type as well, because kubeadmin written in Go, right? So we can start using it as a package by yeah directly going to its CLI interface and just hooking into that. There's no problem there, and then we can start using it like we would normally configure it in YAML, but then we do it directly from code again. And so like this becomes very powerful because now not only do we get all of that really nice, we don't need a CI/CD pipeline anymore because it actually is this is the CI/CD pipeline, right? And if that's not enough for you, if you wanted to have, like a proper CI pipeline with testing and everything, well, you could deploy Argo workflows onto your cluster from code. Because there's also no, like I showed you earlier, there was one part where I can't remember where that is, but where I actually used kubectl directly from the as a package, which turns out not to be necessary, but I will get into that. I still haven't quite figured it out. Like somebody on GitHub gave me a hint to it, but basically you can also just like deploy a normal YAML manifest from the code onto this. And normally I do have a manifests directory, but it doesn't seem that I have one here. Um, However, that doesn't matter. Yeah, and here's the Docker part. But I was starting to use a build kit, and that was a bit more complicated. So like, it might not entirely look like standard Docker, although here, yes, like the tags we are, kind of familiar with. Remove is obviously when you do, you know, we already saw TI, but you also have dash dash RM that once it stops, it removes the container. And then obviously the build arcs, we know that. So in this case, I'm, yeah, setting the user. So we immediately drop down from root. And yeah, here I also set like a Docker registry. This is actually kind of also a cool little trick that I'm using with this Cobra command tool. I've been using this for a while. So if I go into my CMD directory, right, I have my root that sets up the whole Cobra command stuff here. This should look familiar if you are obviously familiar with it. And that allows you to load in a YAML file for your configuration, for your application configuration, right? And then it has a really nice interface to read from that YAML file. However, I didn't want to like have everybody either build the YAML file manually or having to manually manage the YAML file. So what I did was, obviously Go allows you to embed file systems, right? Like into a binary. And that goes with this little magic command here. So it says go embed config star. So that means anything under the subdirectory config star will be now in a var variable called embedded, which is an embedded file system, right? File system type. So here in config, I actually have my kind config, which is like, yeah, like I said, like control plane and 3 workers, which is exactly what we got here: control plane, 3 workers, but also that YAML file, like a default version of it. is directly copied into or compiled into the binary as a file system, and then what I can do in root, right, is somewhere here, it will do like write if not exists. So basically, what it does is like it copies that version, this default version of the workspace YAML to your home directory if it doesn't already exist. So basically, and then if you delete it, it will just copy it back again, right? So it's like, very minimal overhead in the whole in the brain space you need to sort of like get your app up and running, because it actually takes care of a lot for you. And so yeah, why did I get onto this configuration stuff? I can't remember, but oh yeah, because of this. So like basically that allows you to set like the registry that you want to use, and then the username and stuff. Because we have to pull a lot of Docker files basically. And so if I go really quickly to my private repo, can I get there like this? Yeah. Um, Now I recently, like 6 hours ago, apparently. No, I think yesterday I overwrote the entire master branch of what I had before. And what I had before was this backup branch. This was huge. This was getting all out of control. And what I wanted to show here was, what was it? Oh yeah, I have that manifest directory, right? So like for instance, I told you earlier about like wanting to have this sort of shell proxy that like always pulls a Docker file instead of like actually having me, install the command directly. Well, I started, for instance, with, well, actually started with, having a root file system that I would make out of Alpine, I believe. Like, so I start with a scratch image and then, add the root file system directly to the root directory. That was just like purely because I wanted to be completely atomic. So I would actually have the root file system there as well. But yeah, no, it's not that big actually. I don't know why it's not there. And then like I need a shell. So like okay, here's my root file system, right? But I need a shell, right? Like I like Z shells. So okay, then we need a Docker container with our shell. We don't need to install Z shell. We can just run it from Docker directly with a TTY yeah, TTY, attached to it. Okay, after that, we need an editor. So, okay, again, we do a Docker file for a Vim setup, and then probably I would have my Vim RC as well with it. This is kind of older now, so these are not the correct ones anymore. And in this case, I had yeah, I made this a while back. This was actually to remotely provision hardware servers. So this is actually like a Pixie boot setup. To start deploying my cluster onto the data centers and stuff. But you can fully use those manifests as well, whether they be Docker files or Kubernetes files, because I probably have like a lot of stuff that I wanted to install exactly. So I wanted to have Argo CD. I wanted to have like Elastic Cloud. In this case, I was still using Istio as manifest, Lakefs, so data lake stuff, Metal LB obviously because you need that load balancer, OpenEBS for storage, whatever, right? WeaveNet, whatever you wanted, Grafana. So I was still doing all of that from manifests, and then there's likely, well, this is unlikely that I can actually find it for you, but maybe where I actually, no, this I'm never gonna find it. But the idea would be to then actually use the config file right here to indicate which stuff that you wanted to deploy on your cluster, and yeah, I don't think we will see that. No. This does have some of the builder stuff in it, which is like in this one I probably wouldn't even be able to follow it myself anymore. So it became so complicated because it's like building everything from the ground up, and then even Docker, I believe, is like it could be this. No, um, I can't remember where could be this. Yeah, yeah, yeah. It is this. So like I think finally I got actually the Docker daemon actually running as well, and that was not easy. That took the longest amount of time for sure. But right now I'm not entirely sure. Yeah, it should be here. But well, right now I don't think I can actually find that. This could be it though. Yeah, yeah, yeah. So this is actually, yeah, yeah. I think this is it. So this is actually yeah, compiling container D directly into. So it's not the Docker daemons container D that I got to work. So then you wouldn't even have to install Docker, no container D. Um, I believe you still needed run C in this particular instance, and so I did eventually after 2 years cheat a little bit, uh, but with all the intention of still figuring out how to do that. We talked about embedded file systems before. I just basically embedded run C. Run C. I don't know why I still have container D here, but yeah, I embedded run C eventually as a just in a file system, which made the binary huge, and I just sort of write it out to the file system, and then I'm able to use it, right? And then here I was actually trying something really messed up, which is create an in-memory file system to push run C out of it. So run C would be running out of memory directly. That didn't work so well. Um, or at least I didn't get it to work yet. And I've heard stuff that it actually then runs like super slow. So the one thing I still wanted to go over, and then hopefully if for once I actually stick with it, the channel and stuff, um, we will go deeper into this because this is something I'm working actively on. Was yeah the idea of basically not just having kind and back to cluster, not just having kind and a remote cluster, but also to be able to fully automatically provision, right? Okay, so the way that I was doing or trying to do that was to start searching for systems, right? So I made this sort of IP scanner that well here I'm still hard coding it, but like the idea would be this, right? Like it would look at the interfaces on your local machine, scan all of those networks for accessible machines on the network, so for instance SSH. And I think this is actually only searching for SSH. And then if it can find like access to it, so either you would have a password, like a username password configured in your config maybe, or you would have SSH keys in your home .ssh folder. Uh, let's just say that as long as it can find in some way, shape, or form, access to a machine on your network, it could provision it directly because then we have kubeadmin, we have SSH access, so we have a remote shell, and we could use. And did I actually go that far? SSH maybe? No, that's just dial and hang up. Okay. I don't think we have that right now. I don't think we. I don't think I got that far. I got as far as like searching for the machines, but not into provisioning them yet. I think, but it could very well be in here because everything is in here. Like everything under the sun exists in this repository for sure. Even stuff that has nothing to do with all of what I just said. Um, that's a ring buffer. No, no, it could be. No, that's just networking. No, I don't think we got that far. I mean, I know that it starts basically here, and that eventually it will choose like a platform, and then that probably, let's see, new cluster, new scanner. So it does make a new scanner, and then it sweeps, and then well, it does start a new node, but I do believe that just sort of deploys on the local machine. But really, the idea would be to to then, yeah, like automatically take over the entire network as far as it is able to do so, right? And that's really cool because you can actually expand on that and say like, okay, well, if I had, for instance, like a VPN connection to my data center or whatever, then those machines would be provisioned too, and so it becomes a fully like one command situation where you just say like, okay, well, I'm gonna set up this cluster, and then I'm developing on the cluster, whether like whether it's exposed to production or not doesn't matter. It could be, right, like for instance, it could be that you're very far into your project already, and then you want to do a hot fix. Well, it's very simple. Like you just connect your workspace to your cluster, right? Because then you just use the remote option, for instance, because you don't need to provision anymore. So just use the remote option. Now you have an interface directly into your cluster. Could be production, and you could work in a separate namespace. Obviously, like because we have programmatic access, we could instantly copy entire production to a different namespace, do our fixes, right? Deploy it back to the production namespace. And since we're in code, we can obviously also just we can be Git aware. So now we could actually merge back our changes that we made directly in production in a different namespace, whatever. We could take that code and have it automatically merged back into our Git repositories. So it's a really like it's a weird system, but it sounds very good to me. Like it sounds very flexible, very and very very hands off. I mean, the code is really intense and difficult to write, but once it's there, right? Like I'm even going as far as building in my own sort of shell on top of a shell and my own editor, because obviously like VS Code does not have a plugin to work with this, or Vim, right? So I figured like I like Vim, and I'm very happy with it. However, like it's interesting to just like maybe write my own simplified editor that I can use directly as a container deployed onto this thing that I have control over, that I can design, perfectly the way that I want it to use. And then also it's within the philosophy of this project where it is an end-to-end solution. It goes from all the way from development all the way to production to day two operations, because it can deploy an entire monitoring solution through what I showed you earlier, the manifests, right? And but it doesn't even need to be the manifest, because and I think I was actually doing that here. I saw something really quick. It could have been in this one where so hold on, where am I? Yeah, so maybe ops. No, what was this? Yeah, I'm going a bit crazy sometimes with the division of packages. I guess infra. And I think it was actually deployment when we were looking here. Uh, well, anyways, like I saw some stuff that had to do with Prometheus, I believe, but I can't find it right now, so maybe it's not too important. It is not too important. Yeah. So yeah, that's sort of what I'm working on, and kind of what I want to expose as well on the channel, I believe, because I believe it's very interesting. And it, for sure, like if nothing else, it gives you an extreme insight into Docker and Kubernetes, how that all works under the hood, right? Which is nice because I believe that development is going very quickly into an area where we as developers we should probably start knowing all this. I've actually gone as far now to say that when I think of a full stack developer, I think of somebody who also takes care of the infrastructure, and the operations, right? And I really believe that because so much benefit can come from that when you start thinking about these things as a whole, right? Because like Kubernetes has its own entire, network layer. Then you deploy Istio on top of that. That's an entire network layer there. Why would I still build an API? Like when Kubernetes is the API, right? It already has endpoints. It already has ingress. It already has the ability to route to different places, even microservices, right? Why would I still build my own endpoint? Because it's already there. And something, very similar happened in a job not so long ago where I was like, so many companies have asked me to build them dashboards, right? Like for instance, customer success dashboards or any kind of metric related dashboards that shows the data that we are collecting in some form that people want to see. And I don't think I can actually show the exact thing right now because these projects became kind of huge, and then Git didn't want to accept them, or GitHub, and for some reason the thing doesn't work. What is it called? Where you have this separated large file storage didn't quite work. But I had here in this Grafana folder, I had actually three boilerplate Grafana plugins, because Grafana has this whole ecosystem of plugins, right? So if you went to Grafana, what are those React things called again? Storybooks. Yeah, if you go here, then so it turns out Grafana has this entire React-based, sorry, yeah, this entire React-based plugin system where you can have all of the components that you know from Grafana already usable for you. And I'm trying to find a good one. Maybe collapsible section is okay. And then you get the documentation, but normally you also get like I think it's actually very broken right now. That's not uh, uh, unnormal for Grafana. It seems a bit broken, or something isn't going right with my browser. But okay, so here we have a nice little modal window, right? Like, and so when you then look at the docs, yeah, it's really fucking broken. When you look at the docs, you actually get like the way that to use it. Like you can basically just start copy pasting, and yeah, Grafana plugin development is not that difficult, especially if you're good at React. I wasn't so good at React, but this allowed me to save a huge amount of time because I didn't have to make a login system. I didn't have to build like a dashboard where you could make your own panels and switch them around and drag and drop them, because they already did all of that for you. So Grafana allows you to make three kinds of plugins. A Obviously a panel, so you can make like your own little graph. And I made one for Google Maps, for instance, because there wasn't one. And The other one would be a data connector, data source, I believe they call it. So this would probably be normally a Go project or something that connects to an external API, for instance, and then brings it all back and brings it into a form that Grafana likes. And then there is an app plugin, and this actually allows you to directly manipulate the user interface of Grafana, and you can actually get like in the sidebar you get an actual icon, a menu item, and you actually get pages. Like so now you're actually extending the entirety of Grafana's user interface and user experience, right? But it allows you to do so much within so little time, because so much of the boilerplate is already done for you, including the whole UI basically. So you can really focus on getting it to work and getting your data in, and getting if you need to custom panels done. I guess this is a one of the plugins, and it's really just like familiar if you are a React developer. It's You can use TypeScript. I use TSX. I don't know if that's different than TypeScript. I'm not a good you know Node.js developer, but yeah, you can start using all kinds of React packages and stuff. So don't know why I got onto all of that. Oh yeah, day two operations, right? So this is kind of like what I'm working on right now, and I'll try to for once keep things updated, and we'll dive deeper into the code. But for now, you could get to it if you wanted to dive in yourself. You could go to the workspace repository, and I'll link it in the description. This is the new version. This is very non-functional, but to be fair, I guess this one would be as well. But the backup before rewrite uh, is as the furthest I ever got, which is not entirely true. It's like actually only in combination with this one, but you can't get to this one because this is work. But for sure the new version, so the master branch, it will definitely be quickly updated to become as functional as it was. And this might actually super confuse you because this includes like, I don't know, too many things. So yeah, that was probably it. Like that's what I wanted to show you. Um, and yeah, let's see what becomes of it.